Hey guys, the main objective of this video is to find the settlement at any time. We're just going to first recap though the initial settlement, the consolidation settlement, the settlement at any time, and the final settlement. We're then going to be looking at the four cases which you guys could be given, and then once again we're going to do an example. So just a quick recap. In the first video we looked at this graph. I'm just quickly going to discuss it again because it is very important now. So we have the settlement against time. So this value here would be the settlement final, so the final settlement. Initially we're going to get a initial settlement, so SI, which would say be there. We also can call this S subscript C, which is the consolidation settlement, which means that settlement at any time, so say the settlement at this time, we'll call S subscript T. And we said that S subscript T, so the settlement at any time, is equal to the initial settlement plus U, the degree of consolidation, times by the consolidation settlement. So what we're going to be doing in this video is using this graph, which I'm going to explain in a second, to find U, the consolidation, degree of consolidation, which will help us find the settlement at any time. So just before we start, for these types of questions for 3D settlement, there's four cases which could be given. You can either have an impermeable footing and an impermeable base. You can have a permeable footing and an impermeable base. You can have a permeable footing and a permeable base. And you can have a impermeable footing and a permeable base. So what do these all mean? So the footings could be permeable or impermeable. They will either be given to you or you're just going to have to assume what it is. So I mean, you could have a foundation at the top, you could have a embankment, you don't know what the surface is, you don't know what it really is. You're either going to have to be told or you're just going to have to assume what it is. The bases though you can almost always tell. For example, if we were to have a profile of soil, so we don't know what's happening up here necessarily unless they tell us, but at the bottom, if we have impermeable rock, that would be called an impermeable base. If the rock was permeable, or if it was like a sand layer so water can flow through it, that would be a permeable base. So the base you can always tell. The impermeable footing or permeable footing, it's not always so obvious. Most times you'll be told or you're going to have to assume it. So with this information we're going to do an example, and we're just going to be finding the settlements at 2 years. And we're going to be doing this for the examples we did in the previous video. So we found in the previous video that the final settlement, we found this final settlement to be 0.0127 meters. So S final equals 0.0127 meters. We found the immediate settlement or the initial settlement to be 0.0068 meters. So 0.0068 meters. So the first thing we can do is we can work out the consolidation settlement. It's easy to see that the settlement due to consolidation will just be the final minus the initial. So settlement consolidation is SF minus SI, which would be 0.0127 minus 0.0068, and we get an answer of 0.0059 meters. So we've found SC. Now all we need to do is find U, this degree of consolidation. So we have to use this graph, which once again we have to look at our case. I'm going to assume that for our case we have a permeable top, and we're going to say that the base is impermeable rock. So this is the case PTIB, permeable top, impermeable base. This graph we need to find H on A and TV, the dimensionless time. So let's say CV was given to us as 2 meters squared per year. We know that TV equals CVT on little h squared, where that is the layer thickness. So this would be 2 by, we're concerned at 2 years, so 2 by 2 on top of 10 squared, because we know from the question that our depth was 10 meters. So if we calculated this, so 2 by 2 is 4, divided by 10 squared is 0.04. We will also need to find H on A, which are all these values on the actual curves, the H on A. So H on A would equal 10, which is our layer thickness, divided by 3, which is our radius, which was given to us in the question, and this would be 3.33. So now what we do is we'd use these values to find U, the degree of consolidation. So we had TV equals 0.04. So 0.04 is around here, and H on A is 3.33. So here's 2 and 5. So 3.33 will be around here, right? So let's say we come up and get this value there. Once again, my graph's a bit chunky just because I drew it in Photoshop myself, so it's not exactly matching up, but you would come up from a point 0.04 to a value of 3.33 for H on A. You would find that point and come across, get a U of 0.9. So U equals 0.9, which is our degree of consolidation, and then you could find our settlement at 2 years. So the settlement at 2 years would equal the initial settlement, which we found to be 0.0068 meters, so 0.0068, plus U, which we just found now to be 0.9, which is the degree of consolidation, multiplied by the consolidation settlement, which we found to be 0.0059. So if we were to work this out, we'd get 0.9 times 0.0059 plus 0.0068, which is 0.0121 meters, which is 12.11 millimeters. Okay, so you can see that our final settlement was 12.7 millimeters, or 0.0127 meters. So we're almost at our final settlement at 2 years, because our settlement at 2 years is 12.11 millimeters. Anyway, guys, hope that helps.